Greetings, community. My name is Alvin,
My name is Gallardo.
My name is Maryam.
and today we're going to introduce our roller coaster project as a physicist. Our project helps answer the big question understanding, which is why do visionary leaders adapt? And the project focus question, how does the law of conservation of energy explain the motion of a roller coaster, and what in our roller coaster design affect energy transformations and efficiency? The law of conservation of energy states that energy cannot be created or destroyed, it can only change forms. In a roller coaster, this principle explains how the system energy transforms as the ride progresses. The potential energy, stored energy in the marble, changes to kinetic energy caused by the marble's motion following the way of the roller coaster. The sum of the kinetic energy or energy of motion and the potential energy or energy stored in a system caused by the position of its part is called mechanical energy. In other words, an object that possesses mechanical energy is considered to act work.
At the highest point of the roller coaster, the marble has a maximum gravitational potential energy. It's reached its maximum gravitational potential energy, basically, which depends on its height. As the marble goes down, though, the potential energy is converted into kinetic energy, making the marble accelerate. And at the lowest points of the track, the kinetic energy is at its maximum while the potential energy is minimized. Due to the friction, though, energy transforms into other forms, such as sound. Well, and this energy that turns into sound turns lost to the environment and reduces the system's overall efficiency.
A paper roller coaster can model and address several daily life problems based on the work, energy, and power principles. Regarding the demonstration of how gravitational potential energy is converted into kinetic energy and how friction can dissipate energy, and optimizing track layouts and minimizing friction highlights strategies for improving energy efficiency.
So the factors in this paper roller coaster that affect energy transformations and efficiency are the initial drop height and the track material. The higher the initial drop, the more potential energy is available for conversion into kinetic energy, resulting in faster speeds and more thrilling motions. Sharp turns, loops, and inversions increase energy requirements due to potential friction.
Correspondingly, we are going to talk about work and power. Work is said to be done when force, push or pull applied to an object causes a displacement of the object. This is applied in our roller coaster project to ensure that the marble is going to the ground. Related to this is power. Power is the rate at which work is done or energy is transferred. Power also can be defined as the amount of energy consumed per second. Thus, the formula of power is work divided by time. With all of that being said, here's the demonstration of our explanation regarding potential energy, kinetic energy, and work on our roller coaster. We can start by seeing from point A, which is the initial height and the highest point of our roller coaster, which have the height of 54.6 centimeter. The kinetic energy is 0 joules and the potential energy is 0.251 joules since the marble is still in its initial position and it's the starting point to bring the marble to the ground. Point B, which is the second highest point, the height is 24.2 centimeter. The kinetic energy is 0.24 joules and the potential energy is 0.011 joules. Comparing the results of our calculations between point A and point B, it can be concluded that as the kinetic energy increases, the potential energy decreases, and the potential energy turns loss as it converts into kinetic energy. This explanation is in accordance with the law of conservation of energy. Therefore, the energy loss is 0.237 joules. The work done to bring the marble to the ground is 0.0112 joules, and the power to bring the marble to the ground is 0.005 joules. As a physicist, we adapt on using available resources efficiently, responding to challenges such as fixing the deformation of our roller coaster tracks and driving innovation by creating something unique for our roller coaster project. We aim to transform challenges that we face into opportunities to learn. That is why visionary leaders needs to adapt. Regarding the law of conservation of energy, remember that energy cannot be destroyed or created and only transformed or converted from one form of energy to another. Thus, in a roller coaster, potential energy from the initial position transforms into kinetic energy during the descent, and efficiency is affected by friction that causes the energy to dissipate. Now, the real question is, what is the relationship between the two answers that I just gave? Both topics deal with the concept of adapting resources for efficiency. For the roller coaster, a roller coaster adapts energy transformation to maintain motion, limited by efficiency like friction. For the visionary leaders adapt strategies and resources to maintain progress and overcome efficiencies like resistance to change. Therefore, efficiencies and sustainability are the central to both topics. Leaders need to optimize human and material resources, and roller coaster need to maximize energy efficiency while minimizing losses. Hey, Fox here. Alright, that wraps up this video. Thanks for watching, and I hope it inspires you to create your own paper roller coaster to discover more about the law of conservation of energy.